adding more derivatives to your list. Yay, it's just going to grow. So, what is the derivative of a to the x, where a is a number to a power? This is different than like x to the n, where it's x to a number, which is just n, x to the n minus 1. This is a number to the power of x. So, how do I take the derivative of that? It's horrible. What I would recommend is first, you can use the change of base, or you can take, I don't know what I'm recommending now. I have no recommendation. Do I have a recommendation? Yes, I do. Here's my recommendation. You can take e to this, e to the ln of this thing, which would be, if you bring the x down, you have e to the x times ln of a. There we go. Because you can bring the x down as a power. So, what does that do for you? Well, you know the derivative of x e to the x, right? It's just e to the x. What's the derivative of the inside function? X ln of a. Well, it is. So think of ln of a as a number, right? So let's say it was 5. What's the derivative of 5x? 5. Right? But instead of 5, we have ln of a. So here's the last step. We're going to see how we get this to that. We're going to undo that now. So this is ln of a times a to the x. So that's the derivative. You're like, huh, that's horrible. Why is this allowed? Because e to the ln of anything is just that thing. So I'm allowed to do that. I can bring x down in front, because that's one of our rules of logs. And then I can take the derivative of e to the x easily. It's the same thing. And we multiply by the derivative of the inside. Undoing this, which we already said is a to the x, is just that. So, what does this look like? This marker is almost dead. I ordered new markers. They're on the way. I'm really excited. So, what would the derivative of 2? Ooh, that's the stuff. What would the derivative of 2 to the x be? Well, just use the formula. ln of 2 times 2 to the x. Not bad, right? Not horrible. So that is one of your new derivatives that you need to know for Thursday's quiz. Now we're going to do the derivative of log base a of x. So it's not log base 10 and it's not log base e, it's just some log. Okay? How do I deal with that? Well, again, we have our change of base formula. That allows us to change it to any base we want. In this case, I made it log base e on the top and bottom. Do you agree? Disagree? Are you sure? So if I have log base b of x, that's the same as log base new b of x over log base new b of old b. That's your change of base formula. So that's what I use to get this. From there, I'm going to take the derivative. Do I care about the ln of a? No, because it's a number, right? So I can bring that in front. What's the derivative of ln of x? So it's 1 over x ln of a. where a is the base of the log. So how would I take the derivative of log base 3 of x? Well, it's 1 over ln of 3, or x ln of 3. That's just this one. Yay, formulas. More stuff to memorize, more work to do, more suffering. Calvary Chapel Christian School. More work, more suffering. Oh wait, that's just calculus. Okay. Last one. How do I take the derivative of the absolute value of a function? This is tricky. Why? Because this function looks like this. So for this part, the slope is what? Just a number. -1. Because the absolute value of x is just points down. So for this part, the slope is -1. For this part, the slope is what? 1. What about at this point? At x equals -2, what's the slope?
Oh, 2.
So from the left side, it's -1. From the right side, it's +1. So they don't match. So it does not exist.
Oh, okay.
So you really need a graph to figure these out. Once you get the graph, we're going to write it as a piecewise function, which means that we're going to show each piece of this and say what the slope is. So the derivative for x is less than -2 is -1. At -2, it does not exist. And after 2, or -2, it's 1. Because it's -1, does not exist, 1. Gross? Yep. Let's take a really gross one. We have y equals the absolute value, x squared minus 4. Okay, so what does x squared minus 4 look like? It looks like this. If you take the absolute value of it, what happens? What does the absolute value do to a number? It makes the negative parts not disappear. What's the absolute value of -3? 3, right? It makes the negative parts positive. So what it's going to do is it's going to flip this part this way. Yes? Maybe. So these parts still just stay because they were already positive. So this is y equals x squared minus 4. And this is y equals x squared minus 4. But this part, if I were to write the equation of it, it would be negative x squared minus 4. It flips it by putting a minus sign in front. So anytime you have an absolute value, what it does is it multiplies by negative anything that is negative. So how would I write out this function normally in piecewise notation, which is this one? I would say that y equals, and then I have 3 parts, right? I have this part, which is when x is less than what? What's this x value? So a negative 4 would give me 16 minus 4, so that's not 0.
Oh, so confused how you get the number.
So you want y equals 0,
Okay.
so x equals,
Yeah. No, 4. Negative 4.
you got this, man.
Oh, 2.
So this one's 2, and this one's
Negative 2.
-2. There you go, you got it. Okay, so for this part, x's are less than -2, okay? And it follows x squared minus 4. Now here, between -2 and 2, it follows negative x squared minus 4. And then over here, it follows which function?
2. X squared minus 4.
For x is
2. Less than 2.
good. You got this, man. You gotta want it. You gotta want it. That's my name. Okay, so that's the original function. How do I find the derivative? You take the derivative. So what's the derivative of x squared minus 4?
2x.
What's the derivative of negative x squared minus 4?
Negative 2x.
What's the derivative of x squared minus 4? Okay, and then we will keep the same bounds, but at these sharp points, I can't include those, so I just don't put equals. Okay, that's 72. So we